All right, so we're going to talk about scientific notation. You do have a test that's going to be this week. I haven't decided if it's going to be Wednesday or Thursday. I'm probably leaning more towards Thursday at this point, which would mean that your test corrections would be Friday. So hopefully you guys won't decide to not come on Friday. Actually, hopefully you won't need test corrections and we can just do a fun activity. All right, scientific notation. So scientific notation is really simple because you're just going to be using your calculator for the majority of it anyway. This is a unit that you just need to make sure if you don't type things incorrectly in here, you're going to get it wrong. It's just that simple. An error in your typing will cause an error in your answer. So you need to be careful about that. Now, with scientific notation, the idea of scientific notation is just a shorthand method of writing a really long written number. A short written method for a really long number. Oops, I spelled really. Those numbers might be really, really, really large. They might be really, really, really small because even really small numbers are very long written numbers. And typically speaking, when we talk about scientific notation, it is a decimal. When we write it, it's a decimal that ranges between a number that is greater than or equal to 1, but it has to be less than 10. When you write it as a decimal, it's greater than or equal to 1, but it is less than 10. And that number is then multiplied by a base of 10 to a power. Now, when we talk about that power is your exponent. And the exponent for your base of 10 is going to tell you what kind of number you're dealing with in its standard form. So when it's in exponent or in scientific notation format, that exponent's going to let you know you're dealing with either a really, really large number or a really, really small number. So the exponent of your base 10 is going to indicate my green's running out a little, sorry. If your standard form is greater than 10, and if it's greater than 10, then that means it's a positive exponent. Or if it is less than 1, which means it would be a negative exponent. If your exponent is positive, you're dealing with a really, really large number, a number greater than 10, significantly greater than 10. And if it's a negative exponent, it means you're dealing with a number that is significantly smaller than 1. Another thing that you need to make sure you keep in mind is that your exponent acts as a direction for movement. So if you need to translate your scientific notation into standard form, the exponent tells you how to move your decimal. So if you think about it, a positive exponent is going to move in what direction? Very good. A positive exponent moves it to the right. A negative exponent moves it to the left. He's on his way. Here you go, hon. Check online for the notes tonight. Okay. All right, so let's go ahead. We're just going to do 2 practice problems of translating from scientific notation into standard form. So if we have the number 2.08 times 10 to the 6th power times 10 to the 6th power. Again, if I want to translate it into standard form, the first thing I'm going to look at is that exponent. My exponent is a positive. So I'm going to move my decimal 6 units to the what? To the right. 6 units to the right. So when I write out my number, since I know I'm going to go to the right, I'm just going to add a whole bunch of zeros behind this. 2.08. If I add a bunch of zeros behind it, is that going to change the number? No. So I can add a whole bunch of zeros behind it, because who knows, I just want to add a bunch so that way I have places to move past. So right now, here's where my decimal is. I'm going to move 6 units to the right. So I just count 1, 2, 3, 4, 5, 6. So in standard form, my number is going to be 2,080,000. That's it. It's all it tells you is just how far are you moving that decimal. If I have 7.8 times 10 to the negative 4th power, 7.8 times 10 to the negative 4th power. Again, because the exponent is a negative, I'm going to move 4 units to the left. I move 4 units to the left. So I start off with 7.8, but again, I'm having to move to the left. So where should I put my numbers or my zeros? To the left. So I'm going to put a few zeros to the left of it. And now I just have to move my decimal to the left. 1, 2, 3, 4. So that means in standard form, it is 0.00078. Pretty simple? Yeah. So the part that some people might get a little bit more confused on is when they have to go from standard form into scientific notation, because it has the opposite effect. See, right now, our positive exponent has us move to the right. Our negative exponent has us to move to the left. But then when you're going from standard to scientific, you're moving in the opposite direction. So I don't even have you guys think of directions. I just have you think of the type of number that you're dealing with to indicate the type of integered exponent that you're going to have. Okay, so let's go on to the next page, page 85. So we're going to go ahead and do the reverse. We're going to write into scientific notation now. So we're going to write the following into scientific notation. So if I have 523000000, 0, 0, 0, 0, 0, 0. I'm just letting you have it spelled it all out. Looking at this number, the first thing I want to do is identify if I'm dealing with a large or small number. Is this a large or small number? Large. So since this is a large number, what kind of exponent am I going to have? Positive. Thank you. It's a large number. That means it's going to have a positive exponent. Now, I told you guys before, scientific notation, you have to have a decimal that is greater than or equal to 1, but less than 10. So where do I need to place my decimal so that I create a number that is greater than or equal to 1, but less than 10? Between what two numbers do I need to place the decimal in between? Between the what? If I wanted to create a number that's greater than or equal to 1, but less than 10, where am I going to place a decimal to create that kind of number? Between the 5 and the 2. That's where I want to place it. This is where my decimal needs to go. Your decimal needs to be here. Is it here yet? No. Where is it currently? At the very, very end, right? This is where it currently is, all the way at the end. So I now need to go ahead. I know that my decimal needs to be 5.23. I know that. I know I need to multiply it by 10 to some power. Now I just have to figure out what that power is. And how do I figure it out? I count. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's going to take me 13 moves to get there. So my exponent is a 13, and that's it. Again, we're dealing with a large number, so it's a positive exponent. That's where people get mistaken because they're like, oh, but we're moving to the left. Remember, your exponent tells you the direction to move. So right now, that exponent is positive. So if I wanted to go back into standard form, that positive 13 would tell me I have to move it to the right to get it back into this format. So that's why I don't want you guys getting confused about the positive and negative. All right. Number 2, 0.0000037. Positive or negative exponent? Negative. Okay, this is a small number. Therefore, it's going to have a negative exponent. Where does my decimal need to go? Between the 3 and the 7. I need to put my decimal here. So I know that my final answer is going to be 3.7 times 10, and I know it's going to be a negative exponent because I'm dealing with a small number. So now we count and see what that number is. 1, 2, 3, 4, 5, 6. So it's a negative 6. 3.7 times 10 to the negative 6 power. That's the scientific notation. And now real quickly, because you do have to leave real soon, computation. That's where you're going to be utilizing your calculators. So I need you all to get your calculators out. Get your calculators out. And I want everyone to go ahead and you're going to do a memory clear. So you're going to hit clear and on at the exact same time, and it'll pop up memory clear. I need all of you to do that because when you get to final exams, you're going to want to make sure you clear the memory in it so it's in its regular standard mode or its norm mode. Because if you don't do that and it's in scientific mode, it's going to give you weird answers when you're working out your exam. And you only need it in scientific mode for a few problems. But right now, everybody should be, if you cleared it, it should be in a standard form. See the button that says mode? Press that. If you did the correct memory clear, right now norm should be highlighted. What you want to do is you're going to scroll down so that norm is flashing, Scroll over so that SCI, scientific, is flashing, and hit enter. You now put it into scientific mode. If you've clear, you are in scientific mode, you can now start computing. So if I were to give you a problem, this is the easy part, you just have to type them in correctly. If I give you a problem like 4.6 times 10 to the 4th, and I want you to multiply this by 2.1 times 10 to the negative 7th, you can type this in and hit enter. It'll do it all for you. So be careful with how you type them in. Most common mistake is when people are typing a negative exponent, they accidentally hit the subtraction sign instead of the negative sign. Be careful about that. It'll give you an error. But you just have to type it in. You don't even have to use the parentheses. You type in 4.6. Everybody type 4.6. Type your times button. Type in 10. And now your exponent is not a 2, so you cannot use this exponent button. But what button do you use? The one right above it. That's your arrow that will give you a cursor that flashes in the exponent box. You then put a 4. Now here's a really important part. You got to get out of that. Notice it's still flashing in the exponent box. You use this arrow up at the top to get out of it. Then you just type in times. Our next one is 2.1 times 10 to the negative 7th. So now I need to hit my exponent button again. I need to hit the negative sign and the 7. Get out of there and hit enter. And there's my answer. 9.66 times 10 to the negative 3rd. It will do all the computation for you. You just have to type it correctly and put it in the correct mode. Again, to get into scientific notation mode, you hit the mode button and make sure scientific is the one that's highlighted. When you want to get out of that mode, you just hit memory clear and it'll go right back to the normal mode. Everybody clear? Okay, you have homework tonight. It's real simple. All it is transferring, like, so you're rewriting standard form to scientific and scientific to standard, and then doing computation problems. It's very simple.